Okay everyone, let's take a look on my code. So the first thing, well, we created a random forest and with n estimators at 200. So I have tried this on the Dive server and that's doable. If you want to try that on your local machine, I believe it should also be okay. But don't try don't try a super high in estimators, and then well, it may really take a lot of time. And well, usually my philosophy is, well, I start with a reasonably small in estimators, and if I got the result that I'm not so happy with, I want to double the in estimator or try a much higher in estimator, but I want to make sure that the training time is acceptable. And of course, and if you're doing the using the Dive server and you try 2000 estimators, for example, and then you take a lot of resources of the Dive server, Dr. Brown won't be happy about that. Okay, so I do the training and make the prediction, and after that I show the classification report, and then I show the confusion matrix. So for the confusion matrix, clearly the problem is here. So what it doesn't matter it is the first class or the second class, it always got most of them are predict to be the first class, and that is a problem. So well, this is the pain we have to deal with when we have an imbalanced data set. So well, I suspect if we spend the time to balance the data set, and we are going to get a better result. So the next part, Adaboost. So for the Adaboost, and remember we are going to put the decision trees inside, and you may ask, can we do something else other than decision tree? And the answer is yes. However, when we talk about an Adaboost classifier, most of the cases we mean a Adaboost with decision trees. Okay, so in estimators at 300 again, and the learning rate, I'm doing a reasonably low learning rate, and let's see how it works. So I make the prediction again with the Adaboost classifier, and then I show the classification report and the confusion matrix. So it seems that it doesn't matter uh, we are doing Adaboost or random forest, and the performance of those two models are roughly the same. However, I also tried a lower learning rate. So for this lower learning rate, so we are learning a little bit slower. However, we also have 200 estimators, and let's see how it does. So it seems that it's still kind of the same, right? And then I also try to lower the in estimators, and then I lower the learning rate. So, and as a result, I still can have kind of the same thing. So this means originally we used the learning rate to be zero point 0.5, and then we did 200 estimators in the Adaboost. Probably that's already a overkill in this case. Okay, but anyhow, the problem for this one is that the data is really imbalanced, and when you have a imbalanced data set, probably it's a good idea that you should try to rebalance that. Okay, so to sum up, well, we talk about the random forest, and that is an ensemble of decision trees. And remember, we are keeping part of the samples to send to each of the decision tree, and that is bagging. And also, we are keeping only part of the features. We are not using all the features. And the second one, Adaboost. For the Adaboost, we are training a bunch of the decision trees sequentially. So we train one tree, and then we update the weights of the samples. Then we train the next tree to pick up the misclassified samples, and that is controlled by the learning rate. However, well, you usually don't want to use a very high learning rate, because if you try to pick up the misclassified samples too hard, and then you will miss a lot. Okay, so that's it for today's lecture, and I will see you tomorrow. Bye.